All right, 8.3. We're going to learn about another type of sequence in series, which is geometric. So yesterday we did arithmetic, which is when we add to go from one number to the next. What do you think we do in geometric? Multiply to go from one number to the next. So an example of a geometric sequence would be like 2, 4, 8, 16, 32. What do I do to get from one number to the next?
Times 2.
Multiply times 2. So that 2, the number that we multiply by, is our common ratio. And we call that R. We can find R by taking the second number and dividing it by the first number. That gives us our common ratio.
So R is the common ratio?
R is the common ratio. So looking at example 1, these examples are done for us. They kind of just show us what to do. So to find the common ratio, we can divide 4 by 2, and that gives us 2. So our R is 2. It doesn't have to be the first term divided, or the second term divided by the first. It could be any term divided by the one right before it. So in B, if I did 324 divided by 108, this gives me 3. So my common ratio would be 3. In C, notice how our numbers are getting smaller. We never divide to find the common ratio. We would multiply by a fraction. So to find our common ratio here, we would do 1 over 9 divided by negative 1/3. What do I do when I have a fraction in a fraction? Keep, change, flip. So change to multiplication, flip to negative 3 over 1, which this turns into negative 3 over 9, which simplifies to negative 1/3. So our common ratio is negative 1/3. So to find R, you're never dividing, it's always multiplying, but if your numbers are getting smaller, you just multiply by a fraction. So to find the nth term of a geometric sequence, we have this formula here. It's the same thing as the one right below it, but just written twice. So it's a sub n is equal to a sub 1 times R to the power of n minus 1. So a sub n is the number of term that we're looking for. What is a sub 1?
The first term.
The first term. What is R?
The ratio.
Our ratio. And what is n?
The numbers term.
The number of term. So in example 2, we want to write the first 5 terms of the geometric sequence whose first term is 3 and whose common ratio is 2. So we want to plug in what we have into our formula, and then once we have the formula, we can come up with our first 5 terms. So a sub n is equal to, what's our first term? 3 times what's our ratio? 2 to the power of n minus 1. So a sub 1, I plug in 1 into n. Even though it gives it to us right here, we know it's going to be 3, but we're going to plug in 1 and do the math anyways. So it'll be 3 times 2 to the power of 1 minus 1. What's 1 minus 1? 0. It told us. What is something to the power of 0? 1. So 3 times 1 is 3, which that we knew was going to be 3 because that was given. But we can do the math because we are smart. So to find the second term, I'm going to plug in 2. So 3 times 2 to the power of 2 minus 1. 2 minus 1 is 1. So 3 times 2 to the power of 1. 2 to the power of 1 is just 2, and 2 times 3 is 6, yes. To find our third term, we plug in 3. So 3 times 2 to the power of 3 minus 1 3 minus 1 is 2. So this is 3 times 2 squared. 2 squared is
Oh,
4. 4 times 3 is 12. And it asks us for 5, so let's find one more. Nope, 2 more. A sub 4. 3 times 2 to the power of 4 minus 1. 4 minus 1 would be 3. What's 2 to the third power? 8, and 3 times 8? 24. And then the last one, a sub 5. So we have 3 times 2 to the power of 5 minus 1. So 3 times 2 to the power of 4. What's 2 to the power of 4?
16.
16, and 16 times 3?
48.
48. So even though it gave us our common ratio here is 2, that means we multiply times 2 to get from one number to the next. Yes.
No, no.
Yes. We can easily do that without doing all of this math here. You still have to show your work. So I need to see you plug in 1, 2, 3, 4, 5. All right, example 3. It asks us to find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05. So let's plug in what we have. We're looking for a sub 15. It's asking us for the 15th term. What is our first term?
20.
First term is 20, so that goes in a sub 1. What's our ratio?
1.05.
1.05. What is n?
15.
15, and then minus 1. So then we put this in the calculator. Be careful when putting it in the calculator. You have to follow your order of operations. So 15 minus 1 would be 14. So I would put 1.05 to the power of 14 in the calculator first, and then multiply that times 20. What do we get? 39.59. Or 39.6.
Will it tell us what their answer is?
Yes. If the test doesn't tell you what to round to, I will. And WebAssign usually tells you what to round to too. All right, example 4. We have to find a formula for the nth term of the following geometric sequence and find the 9th term of the sequence. So we want to find what a sub 1 is, and r, and n. What's our first term? 5. That's a sub 1. How do we find our common ratio?
Divide the first and second. That would be 3.
So 15 divided by 5, which is 3. So we multiply 3 to get from one number to the next. So our common ratio is 3. And then what is n?
Your last term? Oh, wait, no.
N is just the number that it tells us to look for. So what's that here?
9.
The 9th term.
When was it that n was it like yesterday there was a part where n was your last term?
That's when we do the sum. So we're looking for the 9th term. So a sub 1 is 5 times 3 to the power of 9 minus 1. So we want to do 3 to the power of 8 first, and then multiply times 5.
32,805.
Yes, 32,805. So that is our 9th term. So again, we can sit here and multiply 3 each time until we do it 9 times. But there's a lot of room for mistake when you do that. And if it asks you for like the 54th term, that would take you a long time. You will not have time to do that on the test. All right, example 5. So the 4th term of a geometric sequence is 125, and the 10th term is 125 over 64. And we have to find the 14th term, assuming that all the terms in the sequence are positive. So this, I would say, is probably like the hardest type of question we'll get. We had one like this yesterday when we had arithmetic, where we had 2 random terms, and we had to find one. So we kind of do it the same way. It gives us the fourth term, so a sub 4 is 125. And it gives us the 10th term, so a sub 10 is 125 over 64. How many terms do we have from 4 to 10? 6. You always subtract, so 10 minus 4 is 6. Now when we set this one up, again, we start with the term that's farthest away from our first term, so that'll be a sub 10. And that's equal to the other one, a sub 4, times r to the 6th power. So that 6 goes there. So however many terms are in between, that becomes your exponent. Now we know what a sub 10 is, and we know what a sub 4 is, so we just have to find r. So let's plug it in and solve our equation for r. So a sub 10 is 125 over 64. A sub 4 is 125 times r to the 6th power. What do I need to do first to solve this for r? Divide by 125. What do I do when I have a fraction in a fraction? Keep, change, flip. So this is 125 over 1, because it's a whole number. So keep the top, change to multiplication, and flip the bottom.
So that would be like 1 over 64?
The 125s cancel, so it's 1 over 64 is equal to r to the 6th power.
And then you have to take the 6th root.
Then we take the 6th root of both sides. So the 6th root there and the 6th root there. So it'll cancel out on the right. What is the 6th root of 1?
2.
1.
Oh.
What is the 6th root of 64?
2.
2. So r is equal to 1/2. So that just tells us what our common ratio is. Yes. To find the 14th term, if we wanted to, we could take the 10th term, so this is 10th term, and multiply by 1/2 to find the 11th, the 12th, the 13th, and the 14th. But we can also do it algebraically too. And the way we do it algebraically is kind of the same way that we just did it here, but now we know what r is. So we always start with the term that's farthest from your first term. So is that a sub 10 or a sub 14? Because we're asking to find the 14th term here. Which one's farther from your first term? 14. So a sub 14 is equal to, we can use a sub 10. You could also use a sub 4 if you wanted to. It'll work out the same. What's r? 1/2. And how many numbers are in between 14 and 10? How many? Because that's what it asks us to find the 14th term. We have 4. If we do 14 minus 10, that gives us 4. So that's our exponent. And we know what a sub 10 is. It is 125 over 64, so we're going to put that there. So what is 1/2 to the 4th power? 1 over 16. So this is 125 over 64 times 1 over 16. And then how do I multiply fractions? Just multiply straight across. So 125 over 64 times 16. 1024. So this is our 14th term. This would be the formula way to think about it. So you always start with the one that's farther from your first term.
So it would be like A of F is equal to
Yeah, you could call it that.
A of C to R to the D.
the d, like this number comes from 10 minus 4. So you could say like f minus c, whatever variables you use. Alright, so next we're going to be finding the sum of a finite geometric sequence. So what does it mean to be finite? It has an ending. So it ends. So here we use this formula. So when it's a geometric sequence, it's a different formula than we have when we're asked to find the sum of an arithmetic sequence. So it's this. So what does a sub 1 stand for? The first term. What does r stand for? The ratio. What does n stand for?
Number of terms.
The number of terms. And then r on the bottom again is ratio. So we have to find our first term, ratio, number of terms, plug it all in. So let's look at example 6. We're asked to find the sum. So we could take 1, plug it in, add it to 2, add it to when we plug in 3, add it to when we plug in 4, add it to when we plug in 5, 6, all the way up to 12. But if your numbers are really far apart, that's going to be a lot of work. So that's where this formula comes in handy. How many terms do we have here?
What did you say?
N is the number of terms.
12?
12. It's from 1 to 12. So we have 12 terms here. So we're asked to find S sub 12. That's equal to, how do we figure out what our first term is?
When n is equal to 1.
Plug in 1, because this is our first number. Remember, this is our first number, this is the last. So we plug in 1 into our equation. So a sub 1 is going to be 4 times 0.3 to the first power. So we can just say 4 times 0.3, because we'll put it in our calculator at the end. So then next, I have 1 minus, what is our ratio? Awesome. The ratio is the one with the exponent. So this number,
Is that always?
always. Your ratio is just the number that has the exponent to it. So our ratio here is 0.3. And what did we say n was? 12. And then on the bottom of our fraction, we have 1 minus r, which r we said was 12. Nope, r is the ratio, 0.3, yes. And then we put this into the calculator. So just be careful that you follow your order of operations when putting this in the calculator. Start with the exponent, then multiply. So the sum of our 12 numbers is 1.7. Next, we have the sum of an infinite geometric series. So infinite means that it has no ending. So usually when we have an infinite series, we'll have the infinity sign, meaning that it has no ending. Or you'll see the little dot, dot, dot at the end. That means it goes on forever. So you'll see either one of these, which means it's infinite. So infinite, you use this formula to find the sum.
Where do we see the dot, dot, dot?
Like at the end, if it lists the numbers and then it has dot, dot, dot. You'll see the next example has one. B has the dot, dot, dot. So our formula is a sub 1 over 1 minus r. What's a sub 1? First term. What is r? The ratio. So again, our formula for the sum is a sub 1 over 1 minus r. So let's start with a. So I want to find my first term, and I need to find my ratio, and then I can plug them in. How do I find my first term?
Plug 1 into the equation.
What's the number that I start with for n?
Oh, 0.
So I plug 0 into the equation here. So this is 4 times 0.6 to the power of 0. What's 0.6 to the power of 0? 1. And 4 times 1 is? 4. So a sub 1 is 4.
That's
Trippy, you said?
yeah, it's like,
Gotta be careful.
Supposed to be
Usually
four.
when it's infinity, it'll start with 0.
wait, so if it was like n is equal to 4, then a sub 1 would be n to the
Whatever the n is, the first, that's your starting number, you plug that in. So if it was 4, you'd plug 4 in there and value 8. And that's your a sub 1.
Yeah.
What's our ratio?
0.7.
0.6. So let's plug those in. Our sum is equal to a sub 1 over 1 minus 0.6.
Isn't the number
Yeah, because it ends up being 4 divided by 0.4, which is 10. All right, last one is B here. Again, we have to find a sub 1 and our ratio. So what is our first term? 3. First term's there. What's our ratio?
times 0.1?
So we can always figure out what our ratio is by dividing the second number by the first one. So what do we get when we divide 0.3 divided by 3? 0.1. You're right. So our ratio is 0.1. We multiply 0.1 each time to get from one number to the next. How do we know this is an infinite series? It gives us the dot, dot, dot. So that means it goes on forever. So we use our infinite series formula here. So the sum is equal to our first term divided by 1 minus our ratio. So what's our sum?
3.333.
3.333 repeating.